Hello.
Hi, Shiv. Is Aditya there in the call? Hello.
Hello.
Is Aditya there in the call? I'm joining Nitin also.
Okay.
Mm-hmm.
Aditya supposed to be here. Yeah.
Hello.
Yeah, hi Aditya.
Hi. Wait, is there someone else?
Yeah, one more student Nitin is there just for today's class. So we're going to begin with this chapter of sequence and series today. Let's start with the chapter. How was your trip, by the way?
So it was good. I just got back at like 7 today. So
Oh, okay.
I saw the first differential equations video. I haven't seen the second one, the exponential growth one.
Okay. So let's begin with sequence and series.
So your screen.
Yeah. This chapter is quite different from what you have done for your CBSE. Okay. So there would be some things which are quite new to you. So don't have any prejudice that it is hard or it is difficult to understand, because it all depends upon how you grasp that concept. Okay. So we'll first begin with the concept of convergence and divergence of sequences. Okay. However, this concept is not going to be tested in your AP exam, but it's very important to understand the notation and the terminology involved. Okay. So sequence you already know, it's basically nothing but it's a listing of numbers, okay, where there is a pattern involved. Okay. Now, if I say there is a sequence like this, an, it means I'm talking about the nth term of that sequence. This means nth term of the sequence. This is already known to you. Okay, nth term of the sequence. Okay. Now, when we talk about convergence or divergence of sequences, please note that a sequence an converges, and when I say converges to a finite number L if the limit of the nth term as n tends to infinity is equal to L. Okay. If limit of an as n tends to infinity is not a finite value, okay, then we say that the sequence is divergent. I'll give you some examples to make this clear. Okay. Again, I'm repeating, convergence and divergence is not a part of the AP syllabus, but it is a kind of a prerequisite for you to understand other concepts.
Mm-hmm.
Yeah.
Okay. Let's take a question. Does this sequence, when I write it like this, you understand, right? How is the sequence? The sequence is like 1 by 1, 1
Yeah.
by 2, 1 by 3,
Yeah.
etc. And when I go to the nth term, That term is 1 by n actually. That's how we represent it like this. So this is the sequence in which the terms are going. Now the question is the sequence or does the sequence converge or diverge? Converge or diverge? Okay.
Converges.
All you need to do is you just check the limit of an
So it
as
converges, right?
as tend to infinity. Yes. So basically, the limit of 1 by n as n tends to infinity, that value will be 0. Okay.
Yeah.
Now, please note it is the sequence which is converging, not the series. That means if I add them, I'm not saying the addition will converge or diverge. I'll
Yeah.
come to that a little later on. Okay.
Yeah.
So we read this as the sequence converges to 0. That means the last term will actually go towards 0. Okay.
Yeah.
Please read this as sequence converges to 0. Getting the point? Okay.
Yeah.
Let's take another case. Does the sequence whose nth term is given by 3n to the power 4 plus 5, does it converge or diverge? What will you say?
It diverges, right?
Again, find the limit as n tends to infinity. So n to
It'll
the
be
power
like
4 by 5 by 4n to the power 4 minus 7n square plus n. You need to divide by n to the power 4 on both the numerator and denominator. Correct? Because that is the highest power of n occurring. So it's 3 plus 5 by n to the power 4 divided by 4 minus 7 by n square plus 9 by n to the power 4. And these terms would become 0 as n becomes very, very large.
So it converges.
Yeah, it gives you a finite value, right? L is a finite value. So yes, the sequence converges to 3 by 4. That's how you will read it. Okay. The sequence converges.
Wait, so why do you have to divide by n to the power 4 to solve it?
That's how we evaluate infinity by infinity form of limits. The approach is, yeah, we divide by the highest power of the variable occurring throughout the numerator and denominator.
Yeah.
Okay.
Yeah.
Now, what about this? Let's take another question. Does the sequence an given as 1 plus minus 1 to the power n by n, does this converge or diverge? You tell me the answer.
It'll diverge, right?
What do you think?
I think it'll diverge.
Shreya?
1 second. I think it'll convert. Okay, no, I think actually it will diverge.
It will diverge.
Yeah, because minus 1 to the power.
Okay, so all will depend upon the limit of this expression, right? Limit of 1 minus 1 to the power n by n, correct? Now, whether it's plus n or minus n, as n becomes very, very large, this will become either very small positively or very small negatively. So this will tend to 0, giving you 1. So the sequence will be set to converge to 1.
Wait.
Getting this? Okay, try this one.
But sir, I thought 1 raised to infinity will be an indeterminate form, right?
No, no, no. Tending to 1 to the power infinity is indeterminate, not exactly 1 to the power infinity. Indeterminate form is tending to 1 raised to the power infinity. This is indeterminate.
Okay.
Exactly 1 to the power infinity is not. Okay?
Mhm.
Chalo. Tell me about this. Does this converge or diverge?
Diverge.
What do you say, Aditya?
Yeah, diverges.
So basically, the limit of this as n tends to infinity would become, if you divide by n square, you see the highest degree term here is n square, right?
Yeah.
So if you divide throughout with n square, you will get 1 by, and this is 1 by n, that is almost going to again go to infinity. Okay? So this diverges, this sequence diverges. Is that fine?
Yeah.
Mhm.
Acha, what about this? If an is sine of n,
It'll diverge, right?
what do you think, Aditi, Shreya?
I think it'll converge.
Again, when I say limit n tend to infinity of sine n, right?
Multiply and divide by n.
Yeah.
So it becomes infinity. It'll become n into 1.
We say it diverges because you don't know what's going to be the value. It is something going to be between minus 1 to 1, correct? Okay, so limit, it's not a finite value that it goes to. So it will say it
Okay.
diverges, but we cannot say diverges to infinity.
Yeah, because it
Right?
can't diverge.
Please note that we cannot say it diverges to infinity. Note that it does not diverge to infinity. So you can say it's a divergent, it's the sequence diverges, but not to infinity. Are you getting it?
Yeah.
Again, of a similar nature is this question. An is minus 1 to the power of, let's say, n. Does it converge or diverge?
Uh, it converges, right?
Again, we cannot say because it will diverge because you don't know whether the answer finally will be plus 1 or minus 1.
Mhm. Yeah.
So it diverges because it oscillates. Okay, the reason is because it oscillates.
Wait, why will this be divergent? Didn't we just do a question with minus 1 to the power n and it became, when you apply the limit, it becomes.
No, but there you are dividing by n also, right?
Mhm.
Huh.
But in
So
this
this is
case,
zero then.
your answer will either be plus 1 or it will be
Oh,
minus 1. So what is L? I don't know whether it's plus 1 or minus 1. So it oscillates between these two quantities.
Okay. Yeah. So, but isn't limit of my limit n tending to infinity minus 1 to the power n 0?
Why? Why
Like,
should it be 0?
didn't you just do that in the?
Mhm.
Where did I do
That was
that?
because
Oh,
we divided
okay.
by
Yeah.
Right?
Yeah.
Now comes to the series part. And now the series that we are going to deal with are infinite series. Okay? So for infinite series, now we'll test its nature of convergent or divergent. Okay? Before that, couple of things that you should know. There is something called the power series, or we call it as the P series. Okay. What is P series? P series is where you have summations of term of the nature 1 by k to the power p, where k goes all the way from 1 to infinity, and p is a fixed power. For example, if you take p as 2, and if I say write a p series for it, okay, then you would actually write summation of 1 by k square from k equal to 1 to infinity. That means you write 1 by 1 square, okay, 1 by 2 square, 1 by 3 square, and so on till you go to infinity. Okay.
Yeah.
Now we have already learned the comparison test, etc. in our improper integrals. So you'll find lot of uses of P series in this chapter as well. Okay.
Mhm.
So how do we test whether a given infinite series is convergent or divergent? First of all, let us understand the definition of a convergent series and a divergent series. A convergent series is basically that series where even if you sum the terms to infinity, it gives
Sorry.
you a
I
fixed.
can't hear you. I can't hear you.
Yeah.
Hello, am I audible now?
Yeah.
Yeah.
Yeah. So a convergent series is basically a series where even if you sum infinite terms of those series, we get a finite answer for it.
Mm.
That means summation of k going from 1 to n, where n is very large. If this gives you L, where L is a finite quantity, then we call that series as convergent. Understood?
Yeah.
Yes or no?
Yeah.
Yes.
Okay. Now, couple of examples that you can see is from your geometric series. Uh, tell find whether okay, does this converge or diverge? You already know the formula for infinite terms of a geometric series. What is that? A by 1 minus r.
Mhm.
Correct?
Yeah.
A here is 1. Correct? R here is half. So it's going to be 1 divided by 1 minus half. That's going to be 2.
2.
Is this a finite quantity? Yes.
Yeah.
So this series converges, and it converges to 2.
So you didn't apply limits or anything.
No, I didn't apply limits. No, I applied limits. Basically, I did this. Sum of n terms is a 1 minus r to the power n by 1 minus r. And here r is going to be half. So what I did when I applied limit on this as n tends to infinity, basically what I got is I got this term as 0, because half to the power n as n becomes very large will become 0. Okay. This gives me this result only. Are you getting this point?
Yeah.
Since this result was already known to us, that's why I did not apply limit on it, because after applying limit only this result comes. No. Okay.
Yeah.
So there is a general theory that we normally tell you in your sequence, series, and progression class of your CBSE, that if you have a series like this, okay, where mod r is less than 1, then it would be a convergent series, right? And if mod r is greater than, in fact greater than equal to 1 also, it would be a divergent series. Is that fine?
Yeah.
Yeah.
Understood?
Yeah.
Yeah.
Okay. Now,
Mhm.
I would like to ask you all a question. There's a series like this: 1, half, 1/3, 1/4, 1/n, and so on. It goes to infinity. Does it diverge or converge?
Does it?
Diverge
Diverge.
or converge?
It converges.
Yeah, it converges.
Converges.
Why?
Yeah,
Yes,
converges.
mod r is less than 1.
Mod R. This is not a geometric
Or you
series.
can use it's not a geometric progression.
Yeah, it's
So it converges.
It converges. Why it converges?
So because if you take if from limit n tending to 0 summation 1 upon n, because 1 upon n is your nth term, it will be a finite value.
Come again. Come again.
so it's like
So
the first
if
question
you-
you gave. That an is 1 by n. In this case, an is 1 by n.
So limit n tending to infinity summation of
Uh,
1 upon n
uh,
from n equal to 1 to 1 upon k from n equal to 1 to k
okay.
will be a finite value, right?
Why? Who has told you this?
Mm.
From where did you? Is this is finite? From where did you get this information?
So we substitute if you uh, uh,
See,
fine.
as a sequence, the sequence converges to 0, but that doesn't mean the sum also will tend to 0. Are you getting the difference between convergence of a sequence and convergence of a series? Series is the sum
Yeah.
of all the terms. Okay. As a sequence, it will converge, but are you sure as a series also it will converge?
That's a generally, I mean, I might be wrong, but generally, if the sequence has a finite number of terms, won't the series have a finite sum?
But it doesn't have a finite number.
You have contradicted yourself.
No, but like it's convergence. See, if the series is if the series is converging, won't the so if sequence is converging, won't the series also be converging?
No. Who told you this?
No, so I'm just asking.
No, nothing like that. If the last term is 0, that doesn't mean the entire sum will also be 0.
Okay.
Understood?
Yeah.
Yeah, because people don't understand these small things, they find this chapter difficult. Okay, now this theory is absolutely unproven, that what she has said, so I will not accept that. Okay, now see here my logic. What I'm going to do is I'm going to make this entire series like this. Okay, I'm going to make pairs like I'm going to make groups like this, not pairs, groups like this. Okay, like this. Okay, now see here. This group has 2 elements. This group has
powers of
4 elements.
And then 8,
16.
Like
16.
that. Okay, now see. Now let these two terms be as such. Can I say this term would be greater than 2 into 1 by 4? Let's say I consider both as 1 by 4, 1 by 4. So since one of them is greater than 1 by 4, this entire term will be greater than this?
Yeah.
Correct?
Yeah, and the next one is greater than 4.
So can I say
into
this
1 by
entire series, let me call this as S. This S would be greater than 1 plus half, and this will again be 2 into 1/4, which is again half. Similarly, this term would be greater than
4
2 in
4 into 1 by 2.
4
4
into 1
1
by
by
2.
8.
4 into 1 by 8, correct.
Yeah. And 16 into.
That's again 1 by 2.
Yeah. And 8 into 1
And again,
by
this is
16.
8. This term would be greater than 8 into 1 by 16. That is again 1 by 2. And so
Yeah.
on, go to infinity. Correct. Yes or no?
Yeah.
Now, if this term itself will be infinity and s is greater than that, that clearly
So it
implies
should be
s
divergent.
is divergent. Okay, because
So
this
what
sum
logic
is
did you take to prove this?
this sum is unbounded, so s will also be unbounded. So I'm trying to restrict it within a series which is known to us. Are you getting it?
Yeah.
By the way, this type of series is given a special name called harmonic series. Harmonic series is basically a part of the power series where p value is equal to 1. Okay,
Yeah.
are you getting it?
Yeah.
Now there's something very important which you have already learned in your comparison this thing. When you talk about p series, so I'll take this opportunity to tell you this theory. When you talk about
So
p
to-
series, the very important thing is any p series like this, okay, where n goes from 1 to infinity, it converges if p is greater than 1 and diverges if p is less than equal to 1. Remember
Yeah,
this.
we did this in the comparison test.
Exactly. That's why I wanted to say most of the things that you have learned there. What did you learn there? 1 to infinity, 1 by x to the power p dp, dx. Sorry. Yeah.
Yeah.
What did you learn in this case? When p was greater than
to
1,
convert
yeah, it converges. It converges when p
converges in
was
p is less than 1 and diverges.
and diverges
when p
When
is less.
p less than
p is less than equal to 1. Correct. The same thing is basically represented here. Is that fine? Understood?
Yeah. Yeah.
Okay. So, in light of this, what can you comment about a series like this?
it will convert.
Converges.
So it is following this property, right?
Yeah.
Yeah.
It's p series with p greater than 1. So this will converge. Okay. What about this?
Divergent. Into the power half.
Yeah, it's less than 1. So this will diverge. Are you getting this point? How it works?
Yeah.
Okay. Now, before I diverge somewhere else, let's look into some theorems about convergence and divergence of infinite series. So, theorems on convergence and divergence of infinite series. Okay, first theorem is very important. If summation ak converges, of course, I will not write k equal to 1 to n tending to infinity. Okay, this is just a short form of what I mean. I've already mentioned it's an infinite series. Okay. So if the limit of the sum of ak or a sequence as n tends to infinity converges, then it definitely implies that the limit of an as n tends to infinity would be 0, but not the other way around. That's what is that's what mistake Shreya made. If this is 0, that doesn't imply this converges, but if this limit of the sum converges, that means an has to be 0.
Okay.
Have you understood this concept?
So does it have to be 0 or just any finite value?
No, 0. It has to be 0 for sure. Correct?
Yeah.
That means if the limit is not equal to 0, okay, then you can directly claim that the series
Divergent.
is divergent. Okay, and if limit an as n tends to infinity is 0, it may or may not be convergent. So it may converge also, it may not also. So when this becomes 0, you cannot claim anything about the series. But if you know the series is convergent, that means the limit has to be 0. Are you able to understand this small theorem?
Yeah.
So if you say your limit of an as n tends to infinity is 0, you cannot say that, oh, my series will also be converging. No, we cannot say. Harmonic series was a very good example of this. Correct? Where your 1 by n as n tends to infinity was 0, but still the series was divergent.
Yeah.
Yes or no?
Yeah.
Okay. Now, if you have a series, if you have an infinite series where you are summing this, is this convergent or divergent? Does it converge or diverge?
Divergence.
Shreya? This is your an. This term
I
is your
think
an.
Very good.
Yeah, what's your answer?
I think it's divergent
Why?
because when you no, I just have a feeling. I don't know. I'm not sure.
Why is the feeling like that?
So I don't know. I don't know.
Yeah, I've
I don't
written
know
in
how to
front
do
of your
this.
screen only. Limit an is not 0. The infinite series is divergent. So if I ask you what is the limit of this as n tends to infinity, what your answer will be?
Infinity by infinity, 1%.
So you'll divide by n, right?
Yeah.
Yeah.
So that will be 1 by 1 plus 1 by n. This will become 0. What's your answer then?
1.
1. Is it 0? No.
Oh, it's no.
So what is the answer? It diverges. Why are you so scared of answering? Okay. Are you getting it?
Yeah.
Yeah.
Next theorem. Theorem number 2. If a finite number of terms are added or deleted from a series, it does not affect its convergence or divergence. Should I write it? Okay, I'll write
Yeah.
it. A finite number of terms may be added to or deleted from a series without affecting its convergence or divergence. So it doesn't matter if you remove a finite number of terms. Of course, the what the series converges to will be different if you remove some terms, but the basic nature of it converging or diverging will not be affected if you add or remove some finite terms. Okay, and in a similar way, the theorem also says if the terms of a series are multiplied or divided by a non-zero constant, it does not affect its convergence or divergence. So I'll write that down also. The terms of a series may be multiplied. Multiplied also includes division as well, because if you're multiplying by a fraction, it's as good as dividing. Is multiplied by a non-zero constant. Non-zero constant without affecting its convergence or divergence.
So it has to be one particular number. You can't.
Yeah, it has to be a non-zero constant. Okay. Theorem number 4. Okay. And this we have seen in our comparison test. If summation an and summation bn both converge, then so does summation of an plus bn. Is that fine? Okay. Now, very important part of this chapter, test for convergence. So what if a question comes, test whether this particular series is convergent or divergent, what are the tests that we normally use? Test for convergence. Now, please pay attention here. The first test that we are going to discuss is the nth term test. Okay. Now we have already seen this in our theorem number 1, that if limit of an as n tends to infinity is not 0, then what is the conclusion?
Then the series is divergent.
Divergent. Okay. But if it is equal to 0, the test fails.
You can't say.
Yeah, we cannot guarantee that it has to converge, right? We can't say. So first thing is we see whether nth test is helping to bail us out. If it doesn't, then we have to take care of some other tests. Okay. The next test is the geometric series test. Again, this
is this like is this like a successive series of tests, or like first you see the nth term test, then you go to the
no, not necessarily. Sometimes by the look and the feel of the problem, you will know that, oh, this is not going to help me out. I'm going to directly jump to this test. Okay. That will come with problem practice. So if you have any geometric series like this, okay, then this converges only when mod r is less than 1. That's what I've already discussed with you. Okay. So there is nothing that I have to teach here. I'll directly go to the third test. which is called the integral test. This is called the integral test. Now remember, this integral test only works for those kind of series, okay, where an is greater than or equal to 0. That means it is a non-negative series for all n. Okay, it's also called as a non-negative series. Later on, you'll come across negative series also and oscillating series also, or what we call as alternating series. Okay, so this test, which is the integral test, actually works for a non-negative series. Now, what does this test say? It is the same thing that we had done in our comparison test. So I'll take an example to explain you. Let's say I ask you this question: does this series, by the way, guys, hope you have understood the meaning of this notation. I'm not going to write this time and again. Okay.
Yeah.
Okay, because we are talking about all infinite series questions. Okay. Now, question is: does this series converge or diverge? So first of all, let's say if I'm a person, I would start with the nth term series, nth term test. So I try to find the limit of the nth term as n tends to infinity. Okay, and as you know, I have to divide by n square. Infinity by infinity form, the approach is we divide by the highest power of n occurring in the entire expression, right? Aditya, hope you are aware of that. Okay.
Yeah.
Now this gives me 0 actually. Correct. So it fails. The nth term test fails because 0 doesn't imply anything. It doesn't imply whether it converges or diverges. Had it been non-zero, I would have said it is divergent. Correct. So what I'll do, I'll use integral test over here. What does integral test do? It just converts n to x and just puts a dx over here, and this limit itself becomes 1 to infinity. Simple as that.
So why did you skip the? Okay, because it's not the series test.
Yeah, it's not a geometric series for sure.
Yeah.
Okay. Now, if this integral comes out to be a finite value, then only your series will converge. That means if this converges, then only you can say this converges. Okay. If
it
this
diverges.
and if this diverges, yeah, the same thing. If this diverges, then this will also diverge. Are you getting this point? Is that fine? Understood?
Yeah.
Now, can you evaluate the limit of this? Anybody can evaluate it. Just put a 2 here, half here. Take x square plus 1 as t. So 2x dx will become dt. Correct. So it will become half integral. By the way, it will go from 2 to infinity. Correct, if I'm not wrong. Yes or no? So that becomes half ln t from infinity to 2. So that again is infinity. Correct. So this fellow diverges. So this sum also diverges. Correct. So despite your limit of the nth term coming to 0, it's a divergent series.
So why did it become from 2 to infinity?
When x is 1, t will be 1 plus 1, right?
Yeah.
And when x is infinity, t will also be infinity. Oh, you forgot definite integrals. You have to change the limit of integrals.
Right.
Okay.
Yeah.
Let's take another question based on the integral test. Does this series converge or diverge? N by e to the power n. Does this converge or diverge?
So the answer for the previous one was 0, right?
The answer to the previous one was it diverges.
Yeah.
It goes to infinity, na? So it diverges.
Yeah, okay.
This series diverges. This is correct. Shreya, are you there?
Yeah.
Making sense so far or confused?
Yeah. No, not confused.
If you feel confused, let me know. I'll go slow. Yeah.
No, I'm fine.
Again, will limit test work on this? Try to evaluate limit
No.
n. Please note that this will increase at a much faster rate as compared to this. So this will be 0. So the nth term test fails.
Yeah.
Okay. From this, we cannot conclude whether it's convergent or divergent. So now what I'll do, I'll convert it to an integral 1 to infinity x by e to the power x dx. Okay.
Mm-hmm.
To integrate this, I can make use of integration by parts. U, V. Correct?
Mm.
So U times integral of this would be?
E to the minus x over 1.
Okay.
E.
Plus. Correct?
Yeah.
I skipped a step. There was a minus and a minus coming here. So I clubbed it and make it plus.
Plus.
Okay. So by the way, if you put an infinity here, it will be 0. Yes or no?
Where?
Yeah.
If you put an infinity here, your answer would be 0.
In place of x.
What will it be? Okay, chalo. Let's say I don't know the answer right now. I'll come back to it. Okay. Yeah. What about this? This will be
20.
minus e to the power minus x, infinity and 1. Okay.
Yeah.
So when you put an infinity in place of x, in fact, you should not write like infinity. You should write b tending to infinity like that. You should write. Okay. Can I say this term would be 0?
Yeah.
Okay. So this integral will be 1 by e if I'm not wrong. Okay. Let's evaluate this. Now, normally we write it like this. This is b and limit b tending to infinity.
Mm.
So think as if you are evaluating this as b tends to infinity. Okay. Now again, I have told you that when you have a term like b by e raised to the power b, this grows much faster as compared to this. So this entire this entire limit will be 0, leaving you with 1 by e and 1 by e at both the places. So answer will be 2 by e, which is a finite quantity. So this implies this series converges. You get that?
Yeah.
Mm-hmm.
Just
Let me know when you're done so that I can proceed.
yeah. Yeah.
Okay. Next test is what we call as the comparison test, which you also heard the similar name in integration, the comparison test. Something very similar there also now also we are going to do. Please note this down. If there are two non-negative series, let's say if you have this and let's say some other series un, and both are non-negative infinite series. Okay, listen to this concept. If an is less than equal to un, and it's known that un converges, then it automatically implies that an will also converge. Understood this test? If there are two series and you know that one of the series is a convergent one, and every term of this series is lesser than the corresponding terms of un, then an will also converge. Okay, I'll give you an example to understand this. Does this converge or diverge? Now, it's very clear that summation 1 by n to the power 4 converges.
Yeah.
Why?
Yeah.
It's a p series
Yeah.
with p greater than 1.
Yeah.
Right? Because it's a p series with p greater than 1.
Yeah, and that is less than that.
Right?
The question is
Absolutely,
function.
Aditya. That's what. This term is less than 1 by n to the power 4, right? Because its denominator is heavier than the denominator of this.
Yeah.
So if this guy converges, then this also will converge. That means 1 by 1 plus n to the power 4 will also converge. Okay. So many cases your p series is going to bail you out in this case.
Okay.
Are you getting this point? Okay, try this one. What about 1 by n to the power n? Does it converge or diverge? Now, when you say this, it's actually 1 by 1 to the power 1, 1 by 2 to the power 2, 1 by 3 to the power 3, 1 by 4 to the power 4.
Yeah.
All the way till infinity, right?
Yeah, so p is greater than 1, so it converges.
So, can I say this term, let's keep these two as same. Can I say this term would be lesser than 1 by 2 to the power 3? Yes or no?
Yeah.
1 by 3 to the power 3 will be lesser than 1 by 2 to the power 3. Similarly, 1 by 4 to the power 4 will be lesser than 1 by 2 to the power 4.
1 by 2.
Can I okay, so can I say this series, let's call this as summation un. Okay,
It's 1 plus a geometric progression.
right, this is a geometric series, right? This is a geometric series, and that to its common ratio is less than 1 because it's half, right? If you just remove the first term, if you just bar this first term, and again let me tell you, if you remove certain terms, it doesn't influence the convergence of this. So this still converges. So let's say I call it as an. Okay, so this an is this an, let me not write this term included. This an is a convergent series, correct? And since this fellow is lesser, the corresponding terms are lesser than this, that implies even this will be convergent. Understood how it works? A very, very
Yeah.
well-known test, and it's very, very heavily used. Okay. Now, many a times you will not be able to figure out, looking at the series, whether the terms of one are smaller than the terms of other. So we have an extended version of comparison test, which we call as the limit comparison test. I'm going to stop here because I don't want to bombard you with too many tests at the same day. Okay, you will get confused. What is this limit comparison test? Now listen to this very, very carefully. Let's say an summation an is a non-negative series. Okay, let's say both are non-negative series, an and summation bn. Let's say both are non-negative infinite series. Okay. Now note down these following things. If limit as n tends to infinity, an by bn is equal to L. Okay. Where L is a finite quantity. Okay. Between 0 and infinity. Okay. Not 0. Okay. So between 0 and infinity, not 0 and not infinity. Okay. Then we say both the series, this and this,
Conversion.
diverge and converge together. So if this converges, then this will also converge. If this converges, this will also converge. They will converge or diverge together. Together means if you know the nature of one of the series, let's say you know that this fellow is divergent. Okay, let's say I'm taking an example. Okay. And if this ratio came out to be a finite number between 0 and infinity, not equal to 0, then you can say that even an will diverge. Understood? That's the meaning of diverging and converging together. Correct?
Yes.
And if you know that bn is convergent, then an will also be convergent if this test is holding true.
Okay.
Okay?
Yeah.
If this limit is coming out to be 0, okay, and it's known that bn converges, then summation an will also converge. Why is that so? Because now you're trying to say that this term is actually higher than this term. Okay, in degree also. Okay, so if the denominator converges, the numerator will also converge. Example of this, I'll show you an example of this. Let's say I ask you summation 1 by n square. Okay, and if I know that this converges, what can you comment about summation 1 by n cube? So this is your summation bn. This is your summation an. Correct? So what you will do is you will quickly check this ratio, limit n tending to infinity, an by bn. So an by bn. That will give you 1 by n.
It's 0.
And as n tends to infinity, this will be 0.
0.
So you know your denominator is convergent. That means the series from which bn comes is convergent. So this will also be convergent. And we also know that from power series, if p is greater than equal to 1, it has to be convergent. So it is more or less Yeah, it is more or less reinforcing that concept.
Yeah.
If limit n tending to infinity, an by bn is also infinity, and it is known that bn diverges, then an will also diverge.
Diverge.
Even an will also diverge. Are you getting this point?
Yeah.
This
So
is
if this is an all comprehensive test, why can't we just perform this one test? This fifth test and the previous test. Just not use them. Like this is like an all comprehensive test, right?
not really all comprehensive, because here we need to be aware of a series which we can compare this with. So it comes with a cost of finding these two series where one of the nature is known. But it may fail also. Let's say you found out a bn and an series. An series, let's say the question asked to you. Okay.
Mm-hmm.
Let's say they are asking you whether an is convergent or divergent. Correct?
Mm-hmm.
Correct. You found out
Yeah.
a bn series. Correct?
Mm-hmm.
Whose nature is
Okay.
known to you. Let's say that series is convergent. Correct?
Okay.
Now, you perform this test, and let's say this comes out to be an by bn comes out to be infinity.
Okay.
What will you conclude then? It doesn't fall in any
It's
one
a-
of the category, right?
So either it just be finite or
Yeah. So this comes with a test of, this comes with a cost of predicting a series. For example, let's say I give you this question: does this converge or diverge? What do you say?
Sir, I think it's converging.
It's converging. What do you say,
Yeah.
Aditya?
just a sec. Uh,
So they have just given you one
Yeah.
series. The other you have to predict. So what I'll say, let the other series be summation 1 by n. Okay. We know it's a harmonic series.
So it's converging.
It diverges.
yeah.
Yeah, harmonic series diverges. Remember this for the rest of your life.
Oh my god. Okay, then I think
Because
it diverges.
P is
anyway.
equal to 1.
Yeah.
Okay. Now, let's say I do the limit comparison test.
So you can solve it without that, right?
How? Tell me.
Like using one of the other tests that you gave.
Tell me how. Tell me the test.
Yeah, I know. Yeah, I don't know. I was trying to work it out. I haven't got it.
See, nth term test will not work because as n tends to infinity, this will become 0. So nth test term fails. It is not a geometric series. Correct? Now,
Yeah.
if you have to compare it, you will say that every term of this is smaller than this, but this itself is divergent. So I cannot say anything about it.
Okay.
Had this been convergent, I would have said, yeah, this fellow is also convergent because every term is smaller. Right. So comparison test is also not working. Now what I'm doing limit
what if you-
comparison test.
What if you take a convergent series instead
I'm sorry.
and compare it? And then
What I didn't
Like-
get. I didn't get
like
you.
instead of taking the 1 by n harmonic series, why
Uh-huh.
can't we take a convergent series instead?
You suggest me a convergent series.
1 by n to the power 4 or n to the power 2.
1 by n to
You're
the power.
complicating it.
Okay. No. Whatever he's taking, the test will fail there. So that will not help him out. That's what I'm trying to say. 1 by n to the power 4. Then what do you plan to do with this?
So It converges. Right?
This converges. So, but every term of here is not smaller than this, right?
Acha.
So no, the test fails.
Yeah.
Correct.
Yeah. Yeah.
Are you getting this point?
Yeah.
Okay. Now,
Mm-hmm.
if I evaluate the limit as n tends to infinity, your answer will come out to be half. That's equal to L, which is lying between 0 to infinity, right? So both the series will converge and diverge together, right? So if this is known to be divergent, then this will also be
Divergent.
divergent. Is that fine?
Yeah.
Mm-hmm.
Okay. So I'll stop here.
Sir.
Yeah.
So in the previous one of the previous questions, it was n by n square plus 1. And so you tried the nth term test. So and you divide